before you even took calculus, rather, like if you, like we only know how to find the area of a couple of shapes, like rectangles, triangles, trapezoids, like circles, the things you did in geometry.
Mm-hmm.
And so if we have, like, we now have this like parabola, and if we wanted to find this area here, we don't really know how to do that. That's not one of our shapes.
Mm-hmm.
So what someone decided to do was to estimate that area using these rectangles.
Okay.
So that's kind of like the premise of what we're doing here. And it's called like, they're either called like Riemann sums. That your teacher mentioned that at all, or like rectangular approximations. Like it's not a big deal, but here is the important thing. Let me make this way bigger with this. So in order to find the area of the, and what I'll be interested to see is if this problem is on the test, like if this picture will be provided, because the picture makes it look so much easier.
Okay.
Where it makes it so much nicer, easier to solve. Because what we're really doing is just finding the area of all these rectangles and adding them up and saying, oh, that's going to be about our, the area under the curve. Okay. So if you are not given this picture, the first thing you need to do is find the width of these rectangles. And so sometimes we call that like delta x, it's just a change of x is going to be the width of the rectangle.
Okay.
And so how we do that is, or delta x, usually we say our interval is from A to B.
Okay.
And so essentially we want to take that interval and divide it by however many rectangles we want. So the general formula is B minus A over N, N being our number of rectangles.
Okay. So then for that one, it would be 6 minus 2, and then there's 4 rectangles, so it'd be over 4.
Mm-hmm. And so 6 minus negative, remember subtracting a negative is like adding.
A positive.
So yeah, exactly. So it'd be like 8 over 4, which is 2. And I know the picture's kind of small, but you can kind of see like this left, that far left is -2, and then here is 0 and 2, 4, 6. So you can kind of see the width of all those rectangles is in fact 2.
Okay.
So this first, oh, this is so great. I'm going to color code all this. So this first rectangle, it has, so the area of a rectangle, base times height.
Mm-hmm.
So that first rectangle, the base is 2.
Okay.
And the height of it is based off of our parabola.
Okay.
And notice it's the, so it kind of says here like left endpoints. And so the left endpoint between -2 and 0, the left point will be -2.
Mm-hmm.
And so that height is based off of plugging -2 in to f of x into that parabola.
Okay.
My next rectangle, again, we're going to add up all these rectangles to estimate our area.
Okay.
Again, base times height. So the base is
2.
Still 2. 2 for all of these. And the height is going to be based off of
the left.
Yeah, the left between 0 and 2 would be.
So would that be like, so it'd always be 0. So for like the next one that between 2 and 4, the 2 would be that answer.
Exactly.
Okay.
Yeah, we're gonna actually plug that in and find what like f of 2 and f of 0 is.
Okay. Then plus 2 and then f of 4.
Perfect. And so what I would maybe do at this point is enter in your calculator. I would maybe enter this in Y1. Because then if you go into the table, you can quickly find what f of -2 is and f of 0 really quickly without kind of having to plug in that into that polynomial all these times.
Okay. So then for -2, it would be 2 for x. And then 0 would be 14.
Awesome.
And then 2 would be 19.
I got 18.
Oh, 18. Oh, yeah, you're right. I had something on my calculator that made the 8 look like a 9. And then 4 would be 14.
I'm going to write it out just so you can kind of see, like 2 times 2 is 4. That's the area of our orange rectangle.
Okay.
And then 2 times 14, 28 gives us the area of this rectangle. And you might notice just by looking at it that this other rectangle is that same height.
Oh, yeah.
Same width.
So then 30, well, wait, I did that wrong. 37, 36. 2 times